Good evening, morning, afternoon, or whatever time of day it is for you. It is I, Rick Stevenson, aka Rick, but you may call me Cool Kid Rick for short. And I, your professional quantum physicist and cosmologist, am here to teach you the basics of electricity and magnetism. So let's get started. Now, the first thing you're gonna need to know for electricity and magnetism is the atom. Now, the atom is a very important thing in chemistry and even in physics. As you may know, an atom consists of a nucleus, which is the central part, and the outer orbits. Now, this is a helium atom, so it's got two protons, two neutrons, and two electrons. Rather, this is the common isotope of helium. Now, note this is not to scale. I tried my best, but it just can't be done, at least not on pen and paper. So, the nucleus is around the size of 10 to the minus 15 meters. That's around 1 Fermi, and basically, it's very small. And comparing that to the size of the atom as a whole, it's only 1.4 times 10 to the minus 10 meters. That is also still very small, though slightly larger than the nucleus. So, why are we looking at the atom? Well, the atom has some very important particles that we need to talk about. Now, as I mentioned earlier, these particles are the proton, the neutron, and the electron, which is what we should be focusing on throughout the rest of the chapter of electricity and magnetism. The electron has an approximate charge of negative 1.6 times 10 to the minus 19, also very small. A proton has an equal and opposite charge, so the electron has a negative charge, or it is an unfortunate decision that our friend Benjamin Franklin made when he was deciding what to make positive and what to make negative, as you will see later. But for now, you need to know that the electron has a negative charge of negative 1.6 times 10 to the minus 19 coulombs, and a proton is positive 1.6 times 10 to the negative 19 coulomb. And the neutron, my good friend the neutron, is a simple no charge, because that's what the bartender charged it. So now there are a bunch of forces between charges, and these forces are something you're going to need to know. And as many of you might already know, opposites attract. So here I have a proton, here is the proton, and an electron, this is the electron. So there will be a force between these two charges. Now, depending on whether the charges, if the charges are both positive, both negative, or both different positive or negative charges, there will be a different kind of force. So, as many of you might know, that opposites attract, though not really the case for most students I know. The opposites do indeed attract in this case. An electron and proton attract. So the force of attraction, I'm just going to call it Fe, is towards the center point. Now over here we've got two equal charges, but they are the same charge. I mean, they're both negative. So like charges repel. And this is the same thing for a proton. Like charges repel. Great. Now that we've learned the basics of these forces, we can move on to the fun part. Now, what's the fun part, you might ask? I'm glad you asked. It's time to learn some laws. The first law we'll be looking at is the law of conservation of charge. Now, this is really part of another chapter, nuclear physics and nuclear particles. So it's one of many charges that define, many laws that define a set of fundamental properties that very, very small particles have, called fundamental particles. So the law of conservation of charge basically states that in a closed system, such as this cube, the amount of charge has to remain constant. So as you might see over here, there is a cube with so 2 coulombs, 1 coulomb, minus 1 coulomb, 7 coulombs, and minus 5 coulombs. And the total charge in that will be, well, let's see, that's 9 minus 5, 4 coulombs. And that should be the total number of coulombs in that cube at any given point in time. So after a certain point in time, later, you'll see that some of the particles inside the cube may have decayed or may have interacted with some other particles to form new charges. Now what's important to know that the total charge in a closed system always remains constant. So over here we see that we have an unknown. So we can say x plus 2 coulombs plus 12 coulombs minus 8 coulombs is equal to 4, since that is what was we calculated before. So solving this equation, we get, see, 4 plus 2, 6 equals 4, and we get that the charge the unknown charge in the box is minus 2 coulombs. And that's basically the law of conservation of charge. Now, as you all know, I love me some mathematical notation, so why not give us some mathematical notation? We can define this using the sum of all the charges. I'm just going to represent that using C. The sum of all charges will remain constant. Or, we could just say sum of the charges equals some constant K. K is actually a bad example. We'll just call it P. And now we can move on to the next law. My boy Coulombs Law. Now Coulomb was a French physicist of the ancient times, and like Newton, he came up with a similar sort of law that defines the forces between charges. Now, as we discussed above, we have a certain force between two charges, and depending on the type of charge it is, positive or negative, you will have either an attraction or repelling force. So what is my boy Coulomb's law? My boy is not part of the name, it's just Coulomb's law. So Coulomb's law states that the electric force between two charges is equal to some constant multiplied by the charge 1 times charge 2 divided by the radius squared. Now it's very similar to a certain some other equation that you might recognize. It's very similar to Newton's equation for gravitation, which is just some constant g times m1 times m2 divided by r squared. And that's because they are really similar forces. Now the one difference that you might see is the absolute value over here. Why have I put the absolute value? Because the charges can either be positive or negative. This equation will only give us the magnitude of the force. You're going to have to figure out the direction of the force yourself. Now, Coulomb's constant. Now that's an interesting constant. Unlike Newton's constant, which is constant no matter what, Coulomb's constant is a lot more interesting. And I'll review Coulomb's constant in another video. But for now, all you need to know is that the electric force, the force between two charges, is equal to Coulomb's constant multiplied by the product of the charges, absolute value, divided by the radius squared, the very famous inverse square law. That's all for today's introduction video. More videos will be coming out soon. If you like this video, please like and subscribe and share with people who you think might like it too. See you in the next video.